Okay. Present. Thank you for joining the meeting. This is the June MindSpore TSC meeting. As usual, this is our antitrust policy and useful information that you can check upon. Okay. We'll skip the roll call. And so a review of last meeting. I must apologize again. I didn't send out the minute in time, but so this is things I captured. So during the US Asia meeting, we mostly talked about how to do the university reach out and attending conferences for promotion, and also collaboration on development with Gina. And for the EU Asia meeting slot last month, I captured the comment that we really need a good.
Dropping again, so
yeah, it's the same for me. I can't hear.
Can you hear me? Dropped. Sorry. Can you hear me now? Okay, can you hear me now?
Yes.
Okay. Well, the guest Wi-Fi is not that great. Sorry about that. So I was talking about the meeting minutes from last month. So for the US Asia time slot, we mostly talked about how to do promotions for big conferences, and also we have a development collaboration proposed by Dr. Han Xiao. And for the EU Asia time slot, we received comment about we really need a good tutorial for quick start, and our team is currently working on that. And for university reach out, we need to provide as much as possible free resources and credit. So students want to participate, and also better GPU support is mentioned. So this is the meeting minutes from last month. If there's no objection, so this will be recorded. Okay, let me just quickly share the community progress as usual. So during last month, we again host another MindSpore online learning camp for 2 days. So similar to the first one, we host from May 1st to May 2nd. The second one, we also have more than 220 participated online via WeChat. We have the Bilibili like live broadcast, and we have peak audience surpass 2,000. And we also have more articles published on the social media, well, mostly in Chinese. So for example, we have a individual developer that done a very interesting experiment. So he want to see the data set size, what's the impact, like on for example, one PCS, one PCA essential and 8 PCS setup. So his conclusion is that for large data set, if we use like multi-card ascent setup, the performance gain is really significant. But if we are using really small data set, then just one PC, one card ascent will be suffice. So our team published another article on differential privacy we introduced in last release in MindSpore. So I will try to like translate it into English, hopefully publish on Medium, and I will send out to the TSC mailing list. And also hopefully I can translate this one. This is very interesting experiment. And we continue to host our live talk on TikTok, which is another new media. During last month, we finished 2 sessions with more than 700 viewers participated, listening to our developers talk about the second order optimization and differential privacy, both of which introduced in our recent release. And we, as usual, we released a promo video regarding the 0.3.0 release on the video site. So we have a really decent more than 12K viewership. So some technical promotions. So we have one Hacker News submission for the first time to talk about our MindSpore and WebAssembly experiment, which I will get into detail later. And also I did some Twitter promotion for another experiment we did with MindSpore and the eBPF for the kernel observability. Oh, sorry. And we received quite a nice reception. Hacker News, we managed to stay upon the first page, I think, for a day. So on the community side, all the SIGs, sorry. Yeah, thank you. So all the SIGs has started their like regular meeting, and I encourage them to record their meeting, and I will upload meeting recordings. If they're in Chinese, I will upload to Bilibili, and if they can use English, I will upload to YouTube. And also, the SIGs has started to publish their low-hanging fruit. Low-hanging fruits are like method that adopted by most open source communities for new blood to come in to easily get a hands on. So these are the issue labels with low-hanging fruit you can check out. We try to have each SIG to publish at least 5 low-hanging fruits. So new developers could easily participate in. Okay, so generally our the star fork watch number, the increase rate slowed a bit during last month, which is quite usual. So combined Git and GitHub, we now have more than 2K stars and 1K forks and more than 600 watches. And our binary download number is around 6K. So this is measured through the unique IP. So this is a more accurate account. Again, this is overview of like where in the world that we have people download MindSpore's release binaries. This is quite a nice global community. We have even download from Brazil. Okay, as usual, we will have the our last release review. So we regularly publish our release note in the release markdown file. So I will not go into detail for that, but for okay, I think people still experience latencies. You can hear me, right?
Yes, yes.
Okay, great. So for last release, the 0.3.0 release, the most of work concentrate on release like new models in our model zoo. So this is like a big chunk of work for our last release. Another like new features is we released the second order optimization, which is pretty awesome. So we build upon the idea of KFAC in TensorFlow, but I think the MindSpore second order optimization provides a much better performance wise. Another one is for MindArmor. If you can recall, is our model evaluation toolkit. So for MindArmor, we add the differential privacy capabilities, and we adopt what we call a adaptive differential privacy. So the Gaussian noise is being added to the model following a adaptive rate, so that we ensure the training process it is still very performant while using the differential privacy techniques. So if you are familiar with traditional ways of utilizing differential privacy, you will know that typically the performance will have a significant hit, since we are adding security measures to the whole training process. But for our adaptive differential privacy method, we kind of ensure the training performance stay on target as we usually have for usual training. Okay, now the team is working on our next release, which is 0.5.0. So first of all, let me explain why we skipped a number. Because as I mentioned, so last release we shipped a lot of new models, which we still have to have a little more hardening and some trailing features we need to add. So we will probably follow up with minor releases like 0.3.1 or 0.3.2. But at the moment, there will be like new features already shipped in the minor release. Hello.
我居然看到了 Peter 里。
Kai, can you mute?
我居然看到了 Peter。
Can you mute?
对 ，Peter 就是帝国理工那个 Peter。
Sorry about that. So since these reasons, I think it's a good idea to skip the number 0.4.0, because if we release 0.4.0, there will be feature clashes with the previous minor releases. So we'll go into 0.5.0 release, which in effect is a beta release. So MindSpore will go into beta by the end of the month. So which is a kind of a big deal. Our release manager, as usual, has sent out our release plan in the mailing list. You can check it out. And also the whole release cycle management is published on the wiki, also publicly available. But another big thing is that we will propose a new seed called AKG. I think we have our colleague can talk in detail. So who will be talking about the AKG seed proposal, or should I do it? Hello. Ren Wei, can you?
Okay.
Can
you hear me?
Yes. Do you want to share the screen, or I share screen for you?
Hi, can you hear me?
Yes, I can. You can talk.
Okay. Okay. A little lag here. Okay. Next, I will give a brief introduction to the AKG proposal, that is autokernel generator. So first, summary. AKG could be considered as an optimizer for operators in deep learning networks. It can work with MindSpore graph kernel to provide the ability to automatically fuse the operators with specific patterns, which could improve the performance of network running on different hardware backends. As we know, fusion can improve the performance of deep learning network significantly. However, the fusion pattern varies in different network, so it is hard to cover all fused operator manually. That's why we developed AKG, which could generate high performance target code for these patterns on different hardware backends. And so the goals of the AKG are two aspects. First, it can provide the ability to fuse operators with specific patterns in REST 50 and word night and so on. And then uh, and, and, uh, and then it can provide the ability to generate a high performance target code for these patterns automatically on different hardware backends, such as the GPU, the bench cores, and so on. Here, next we will talk about the proposal. There are three basic process content in AKG as follows. That is operator expression, schedule initialize, and instruction emitting. First, AKG defines several basic operators which can be used to compose a complicated fused operator. These basic operators have the same granularity with MindSpore IR. So here we introduce JSON to express the relation of the basic operators in one fused operators. And when AKG obtains the DSL of operators which would be fused, it could transform the operator DSL into formula IR. Now we use highlight IR as TVM, and then into the ISL schedule tree. Next, the polyhedral schedule process begin with the help of Pluto algorithm and other optimization. The schedule tree will do some transformation, including vectorization, loop tiling, and memory promotion, and so on, which can help us to improve the parallel capability and the data locality. Then, in order to generate correctness and high performance codes for different hardware, the IR should be optimized respectively. That is the instruction emitter process did, such as the double buffer optimization, storage rewrite, and so on. Here are two user stories. As we know, deep graph optimizations and optimize dynamic network. I will introduce the second one. As we know, networks are exhibiting more and more dynamism, especially in the field of deep graph analysis and NLP. So tensors in a mode may have dynamic shapes such as batch size, image size, and so on. Within this different dynamic requirement, AKG can generate one general target code on different hardware. For example, DaVinci hardware, and use this code for different shape of common operator. Next is the design details. AKG compose 4 basic optimization modular, as we can see in the graph. That is nomination, auto schedule, instruction, emit, and backend optimization. In the nominalization step, first the AKG will translate the DSL, the operator DSL into an IR, then normalize the IR. For example, loop partition, system rewrite, and so on to make the IR normalization, which could processed by polyhedral. Then in the auto schedule step, we use polyhedral to help us do some transformation, such as loop tiling, promotion, and so on. This path could help us to improve the data locality parallel capability. After poly, AKG will continue optimize the backend IR, mapping this to loop to hardware instruction such as CCE and so on. The relationship between next graph, okay. The relationship between AKG and the MindSpore, we can see this graph. When graph kernel is enabled, operators are reconstructed in the graph level. The new operators described in the format of JSON will be translated into the operator DSL in AKG and then compiled to the target binary. Here is next is the test plan and the implementation history. We will not introduce anymore. The last is the drawbacks and the alternatives. First, the drawbacks. There are some issues on both correctness and performance of the schedule generated directly by Pluto algorithms during the polyhedral process in some scenarios. So we have to add some extra passes to make the IR correct. Maybe this is the drawbacks now. And alternatives, before we developed AKG, we considered TVM and the TC. And as we know, both TVM and TC are outstanding tools which can automatically generate a high-performance machine learning kernel. However, neither of them could generate the codes for DaVinci cores, as DaVinci cores have more complicated multi-level memory design, as well as specific data flow constraint. Besides, TVM adopt the schedule-based model and have to write the schedule all by ourselves. Well, AKG used the polyhedral techniques to initialize the schedule automatically. We referenced from the designing of TC. The last is the reference, and that's all.
Okay, thank you very much. Any comments at the moment?
So can I ask a question? So, so did you consider extending TVM with support for DaVinci cores?
Yeah, that's a great question. Renwei, have we considered just like extend TVM and contribute the DaVinci Core adaptation?
Yes, yes, that is TBE. TBE have done.
Okay, I think what
we have another tools TBE and use TVM.
Yeah, I think
Sorry?
what Renwei meant is that
I can't hear exactly.
no worries, I will explain for you. So I think what Renwei mentioned is that for DaVinci Core for Ascend, you already have the TBE, which is based on TVM for a lot of the work. So the AKG here is mainly used by MindSpore. MindSpore for the fusion operator and the operator generations. So I think what he mentioned is that we have to, if we just extend TVM, there will be a lot of hacking in the core code. Oh, Jesus. Sorry for the noise. So I think they have to do a lot of hacking in the main code. So the extension will be not trivial. So that's why the AKG proposal sort of like adding polyhedral capabilities to some of the basic TVM capabilities. Yeah, I don't know if that answers the question.
Yes, yes, it does. I think that makes sense. Thank you.
Yeah.
May I ask also a short question?
Yeah, sure.
I like this whole idea of kernel generation and optimization. Do you have any text where it would be possible to see the so to speak, the original program in a high-level language, and then what you really generate for it? For some example, maybe simple example, like that we can really understand what kind of fusions, for example, have been done, and what is the quality of the code. As far as I understand, it will be CUDA, which will be generated after generation, and which will be produced after generation and optimization.
Yes, I think that's another excellent question. I will ask the team to provide like a sample code, right? A sample process and add it to the proposal, so it's to make it more clear.
Yeah, okay, thank you. Yeah. So for example, I don't know, for matrix multiplication or for convolution, or I don't know what you have in mind, but it would be nice to see and to be able to compare to what people would write manually, and what would you then generate and optimize automatically.
Yes, of course. I will ask the team to provide such sample.
Okay, thank you.
Okay, no problem. Okay, so the proposal is submitted as a PR in our Git side. I will also ask Renwei to submit this PR to the GitHub. So every TSC member could take your time and do the review. There's no rush, so feel free to ask any questions, any comment. You can send your questions or comment in mailing list as well. Okay, so as usual, we have 1 week open for questions, suggestions, and comments, and yep. Okay, I will send out the link after the meeting. Okay, this is I think much of the next release big bulk of the work. So this is actually an action item from last meeting. So I think we will be gradually setting up a like learning groups for MindSpore. Since MindSpore is still in early stage, I don't think it's appropriate to have a user group. But definitely we can have learning group that we can get people who's interested in MindSpore together to learn the concept and have a quick hands-on. So here's a very simple proposal I think we can do. So we can, if there's any volunteers that they want to spontaneously set up a learning group, they can send email to our public mailbox, and we'll have people help them to start a group and sending any logistics if we can, and also help train them. So this is a quick thought. Yeah, sorry,
So,
I'm
excuse me.
yeah,
Sorry
I'm on
to
the
interrupt. The Zoom call
yeah.
will terminate, right?
Yeah, I'm still on the freemium plan, so it only gives me 40 minutes free time. Sorry about that. Yeah, so I think I also have run up my list of items. Yeah, I think we have a little bit more time. If
Great, thank you very much. It's very exciting. Is there, in terms of the differential privacy implementation, has that been published specifically, or is it based on previous published work? Or so you're saying there's some additional
yes,
dynamic computations that are being put in there for the differential privacy?
yeah, I think that
how much that is verified.
yeah, I think the team is working on a paper. So yeah, so all the implementations has already out with the last release, and I think they are working on a technical paper to explain all the techniques behind.
Great.
Yeah, I can check when they can release the paper, hopefully, and I can send out to the whole community for review.